This is a 1926 Sparton 5-26. Cabinet's a bit rough. I'll show you the top here. Finish is kind of coming off a little bit, but we'll take care of that later. Now let's open it up. Looking at the front, this is another one of those nice metal that looks like wood. Got a potentiometer here, probably for filament. Got one knob which controls this dial. See that? And we got this other knob for these two dials, and this one seems a bit stuck. Actually, this one's moving, and that one seems stuck. So I'll have to get into that. Got a switch down here. It says off, N, and D. So I'm going to guess that this is for near and distant stations. Be my assumption. I can check into that later. And we got another potentiometer, probably for volume. I don't know if I mentioned this is probably for filament. Since this is a battery powered radio, you have to adjust your filament voltage as your battery drains down. Take a look at inside. So I believe all the tubes in here are type 01s. Yeah, 01A. These are keyed, yeah, see the key is there. Matches up with the key on the tube. This is part of the detector. See how it's mounted so it can move. That's the detector, that's to prevent microphonics and such. And this tube here can be a power tube. I believe this is not one. No, it's an 01A. If you wanted to, you could put a 112A in there, and then you'd use these extra terminals back here for more voltage on that tube. I do have a spare 01A that I took out of that Stuart Warner. That Stuart Warner had one 112A and one 71A. So I got another 71A to put in there. So I'm going to have an extra 112A. So maybe we'll try that in here. Other than that, not much to see so far. We do have a couple dial lights in the front there. Don't always see those on battery radios. But I guess the next thing will be to take this out, see if we can loosen this stuck knob, and go from there. So the battery radios always have these terminals to connect to the batteries, and these nice ancient, oop, that one came off, alligator clips for hooking on the lead acid filament batteries. But we're going to use something a bit nicer than giant lead acid batteries. So for now, we'll just take this apart and get working on it. Alright, so I got this out of the cabinet. I had to take 4 screws out of the bottom, and also this board, which sits, it just sits on top. It just sits on top like that. Take a screw out of each end of this, and then this comes off. It has a wire on the bottom of it here. I'm not sure if that's so if you have like one 45 volt battery on this side and one 45 volt on this side, you could chain them together to make the 90 volts. I'm not 100% sure, but that's my best guess for that. Let's turn this around and take a look at what it looks like on the other side. This is the back here. See our audio transformers. Where's my pointer? Yeah, I got audio transformers, some capacitors. I'll probably replace those. These look like the same kind that was in the yeah, AC62 or whatever it was that I worked on before, where these ends just sometimes, it looks like it might be separating already. These ends sometimes just, don't seem to be on. But we'll replace these anyway, just for peace of mind. Got our battery wires here. Of course, these aren't labels, I'll probably have to find a schematic somewhere to see what they all are. Pretty obvious that these are the filament wires. They've got no ends on them because these clips all broke off. There was a clip on each end. You can see the wire just broke off there. I'm probably just going to solder these wires right to the new battery pack that I make for this, and not worry about these clips, because these clips might not be original anyway. You can see that there was a little end on here that they bolted onto the clip, so I'm not sure if these clips are original or if someone put these on and bolted them on. Anyway, so the first thing we'll do is see if we can flip this over. See if I can get something to rest it on so it's not resting on the tops of the tubes. Is that going to work? No, it's not tall enough. I would like it to be taller. That should hold that up. So let's take a look at the bottom here. So this is the one that turned. This is the one that did not turn. Okay, so you can see this one turns a little bit, but this one on the end is, oh, it moves. This is just not, doesn't move freely enough. At the end. Anyway, let me put some oil on this and work it back and forth a little bit, see if I can free that up, because it doesn't actually seem too bad. After putting some oil on this and working it back a couple times, it seems to be a bit better now. I turn it most of the way, but then it gets stuck right here. It just slips the rest of the way. But if I turn it backwards, it goes the whole way. So I think there's just still something a little sticky in here. I'll have to see if we can clean it out. Actually, there might be some dirt back in this one. Maybe we can clean that out. But since at least this turns somewhat now, I'm going to move on to checking some other basics. Once we verify this will actually play, we can come back to this and get it fully perfect. So next I'm going to check these audio transformers, since they like to go open. So let me get my meter. Actually looks like this one, oops. Actually looks like this one here has some writing on it. Not sure if you'll be able to see that or not. You can't really read what it says anymore, but looks like it was there at some time. And it almost looks like a little kind of diagram here with some little wires coming out. But then again, maybe it's just dirt. Let's get the meter in here. And I'm going to assume that on this side, this goes to the grid of this tube. Looks like the grid, and this goes to the plate, so let's check if that doesn't look promising. Well, let's try those connections on the other one, see if we get the same thing. We do. Okay. And I'm being stupid because that's not the way this is wired. This would be the plate going to B+. Let's try this, measuring the right thing. $4.5K, that seems appropriate. And this would be the grid going to either ground or bias resistor. That's just dirt. This is the wire going over here. $1.6K, that seems appropriate. And we'll try measuring this guy, which goes here, I think. Looks like it goes there anyway. Well, maybe we are done. Alright, that might be open. Let's try the other side just to see what happens. Oh, the other side looks okay, 1.9K. 1.19 rather. 1.19K, that's okay, but this side is looking a bit dead. Alright, well, I guess what I can do is pull out, I still have one extra audio transformer from the time I worked on the RCA Radiola, what was it, Radiola 66, to replace the audio transformer. I still have one left from that, I think. So I'm going to get that and see if we can at least tack that in temporarily to see what we get here. Alright, so we got our slightly waxy, so a big blob of wax there, replacement transformer. Let's see how this one checks. Have to figure out what wire is what too. So let's go with these two left ones first. Left that way. I'll get the meter. Okay, so that seems to be nothing. Let's try this wire here. That's coming out the same side. Well, maybe this transformer is bad too. Well, alright, there's something. 1K on these two. See which ones I'm pulling on. These two, top and bottom on the right. So that means that these two on the left should be a pair. I'm not getting anything. Alright, let me investigate this further. Hopefully there's just a break in one of these wires here. Okay, so since both of our audio transformers seem to be no good, we're going to try something else. We're going to try bypassing the audio transformer with capacitor 1 microfarad, or no, 0.1 microfarad, and a resistor 22K. And just to show you on the schematic here, this is the transformer that we have a problem with. So this winding, this winding here. Is it the other way around? I'm going to double check this now. Hold on a second. Okay, it's actually this winding that's open. So I should get a different resistor. We should probably use the 100K resistor there instead of the 22K that I got because I thought it was this one. So we'll bridge a capacitor from here to here to get the signal across, and we'll put a 100K resistor from here to here to give this the correct bias. And also while we're in here, we replace this capacitor because from here you can see that it's kind of starting to separate there at the end. Sure if you can see that or not. Yeah, that's just done. So we replace that while we're in here too. That is, well, that's really the only capacitor here. This guy, 0.5 microfarad. So we'll wire that stuff in, and I think then we'll be ready to hook up the batteries and see what it does. I did check the 2 potentiometers on the front and those checked out okay, so we'll go from there. Alright, so I just soldered the filament battery wires onto this little 6-volt battery pack. This one looks kind of messy, but the plastic started melting as I was trying to fix it, so I'll have to stay that way for now. I've got my meter here hooked up to one of the filament voltages on the tubes, so we're going to turn this on and try and adjust it. I believe this one adjusts the regular tubes and that one adjusts the detector tube. We're going to turn this on and try to adjust this to 5 volts. Turn it for distance just to see what happens. So far nothing. Let's start. Well, that's rather uneventful. I wonder if this switch is not working. Try adjusting this one. That has no effect either. Okay. I guess I'll have to check that switch out then. Okay, so the switch only seems to work in near mode. It's on the end now. I'll have to worry about that later. I'll have to check out what that switch actually does as far as N and D. I just assumed it was near and distant, but we are going to double check that. And this one adjusts whatever tube I'm hooked up to. I think I'm hooked up to this one. This one seems to be adjusting that, so I'll put this up to 5 volts if we can. Yeah, good enough. Oh, that is the detector tube. Okay, let's back that off a bit. The detector tube you set for your volume. So let me check where I'm hooked up and why that's adjusting everything. Okay, so this adjusts the voltage for the 2 RF tubes, and that adjusts the voltage for the detector and all the audio tubes, which is an odd configuration, although probably if I had checked the schematic like I should have, I would have seen that. Where is it? Let's see, here's one of them, 10 ohms, that filament, and here's the other one, 10 ohms for Yeah, all those. So it's obvious if you actually read the paperwork. And here's the switch. And it looks like it just has 2 connections on there. Alright. Yeah, okay, so... Okay, so this must be ground. And one way connects to A minus. Okay, so... Looks like it's that just turns the filament voltage on and off. So this would be the negative of the filament battery, and that just connects it to ground, so that current can flow through the filaments to ground and back to the negative of the battery. And this other wire goes over, oh, just the lights. Okay, so I guess it just turns one way. It turns. It's interesting. Okay, that must be night and day. Must be N for night turns the lights on, and D for day leaves the lights off. Okay, so both positions do seem to be working. Now it's on D, and the lights are out. And if I turn it on N, the lights go on, and we get our voltage. Okay, so looking at this, right around 24, I'm going to say, is about 5 volts. So we don't want to go past 24. We can turn this down to adjust the volume as needed. Just don't go up past there, because that would be more than the tubes are rated for. So we can turn that one down now that we know its setting, and we'll go to check the other tubes. Oh, you don't need to watch this. It's just going to be the same procedure for the other side. So I've been playing around with this for a little bit. Got my speaker in the back there. And I got some 9-volt batteries in the back for a high voltage battery. So this is susceptible to microphonics. Can't really hear it now though. Get off station. Let me turn the front end down. Slow that noise. Now you can hear it. Not as much on those, but definitely on the springy one, the detector. That's why they mount it that way, so that any vibrations the speaker introduces into the table or wherever you have it setting on doesn't feed back into the tube. Let's see, where were we? The question is, can I get a tune back again? That's oscillations. Let's see if we can tune the... So turning the gain with the power on the audio down quench the oscillations. If I turn this back up, now the front end has too much gain, it's oscillating. If I turn this down more, it dies out pretty quick. The other knob is for the audio circuit. It almost sounds like oscillations there too.
but a wet when you get beneath Golden State and Houston.
Sounds better there than it does down here.
10th place, separated by 4 games.
It's kind of interesting. And it does sound like oscillations down there.
Beat the Warriors twice handily, then got destroyed by Golden State.
Up there sounds pretty good though.
Orlando the other night struggled with some 14.
Let's see if we can get some other stations. Actually, let's turn off the lights. See how much those lights shine through this. It is readable. I'll show that it's readable in the camera. You can get in on that. Yeah, that's definitely adequate lighting. See if I can. Probably isn't going to be that selective.
Order, read it, and enjoy it. Those are your orders. And I 9 minutes. Therefore, I'll give the phone number 617-254. You want to call in and talk about Ella? You can. If not, I got it.
There's another station. So I like to adjust this and a little bit of this. This one is the coarse knob kind of. These ones are more selective.
Wonderful things about him, and a few not so wonderful, but he did help turn Ella Mr. Grant and Mr. Sinatra intensely dislike one another.
So I adjust this until I kind of hear something, and I try to keep this somewhat in line. So like if this is up here at, what, 33 about? This one on the end is up here about 33. Or 34. I don't want to have this one like all the way out at like 50 or something. I try to keep them somewhat in line. I try and adjust this till I hear something, and then adjust this to bring it in nice and clear. Seems to be drifting out now. See if we can find something else. It's kind of a little bit quieter, but that's the station out of Canada that broadcasts old radio shows at night. If I turn this up anymore, it's going to oscillate. But anyway, if you can hear, that's an old radio show from about the 30s or 40s probably. I notice these tubes glow a much brighter white than the later affiliated, these are affiliated tungsten, the later oxide coated filaments glow These filaments are thoriated tungsten, so it's tungsten impregnated with thorium, and it has to glow a lot brighter than the oxide-coated filaments in order to have decent emission. So after this, they came out with they started coating the filaments in oxide to increase emission, and that's when you get the tubes that glow red. These ones glow yellowish white. And before this, when they used pure tungsten, like in the type 01s or type 00s, those ones glow bright pure white. But I think that's going to be pretty sufficient for that now. I'm going to have to work on loosening this up, because it still sometimes doesn't want to go backwards. See, it still sticks there. Actually, might be a station there. Maybe not. Yeah, that's all sticky. And then back to the beginning and start over.
When it comes to dieting, the all or nothing approach is really not advised. This approach
But you can play with that all day. Worst of all, I got a copyright strike for this song. This is a oldies station. They're pretty low power. I think they're only 250 watts, and they're on the other side of the mountain, so they don't always come in that well. But I think it might just be dirty controls on this one. So we're on the verge of oscillation. So I have to go over all those controls again. The dial seems to be working better now. I put some beeswax on, and you can pretty much tune through most of it. So something else that I wanted to try is, since I have the extra 112 tube, I'll hook up some extra battery that needs an extra C battery, which is 4.5 volts, and an extra 45 volt battery to drive that at 135 volts. And for the batteries, all I did was, you can see I've got my A battery there, just 4D batteries in the little holder, and I soldered the wires on since the clips had fallen off. And over here, that little pack there is 4.5 volts for the C battery. We're going to have to find something better to mount that on, because it's kind of just hanging on the wires now. And then down there is my B battery for 45 and 90 volts. I don't know if you can see it or not, but on the side of that tube it says detector. So I'm not quite sure what kind of verification they had to do to verify as the detector, if they did any kind of verification at all. These ones, you can see the filament through the top. That one you can see it on as a reflection out the bottom, but not through the top. And this one, I'm not sure if you can see it all. A little bit on the reflection. But this is the power output tube that I'm going to see about replacing with a 112. And that's these extra connections here. They're just jumpers since it's an O1A. When you put a 112 in here, then you hook up an extra battery there. And the holes in the back don't quite line up with the connections on the back of the chassis. Kind of interesting. Anyway, it's getting there. I took it back out of the cabinet to work on the switch to see if I could clean it up. Kind of an interesting construction for this switch. The shaft goes in the front, just the shaft with the pointer on it. I sanded this down with some sandpaper. I'm not quite sure what exactly grounds it. I'm not sure if it's supposed to get ground just by going through the front of the cabinet, or whether this piece, the detent, grounds it. Because then this goes on. And the shaft does have a flat spot on on that side for these things to ride on. So I'm not sure whether the detent against here grounds it, or whether the shaft going through the front, through this sheet here, is what grounds it. I'm not quite sure. All this switch does is connect one side of the battery to ground. So the negative side of the battery comes in the back, and then that wire goes up here to this terminal on the switch. So when you turn the switch on, this ground coming through the shaft connects to the negative side of the battery to let current flow through. And this other terminal here is one side of the lights. So when you turn it into the night position, then the copper bridge spans here, here, and the middle. So this ground, one side of the lights, ground, are connected to the battery. So now that we've got the detent on, then we get this spring. Let's see if I can do this. It looks like this, by the way. It has one lump, the center, and then this end here. The small circle goes into the detent. The small circle goes into the detent. The big circle sits on a post here, and the end goes under this little hook here to make a springy detent. See if I can keep this on. You can see the detent action there. This is falling apart now, so I'm playing with it. And then when that's on, this piece goes on. That gets 2 screws. I'll tighten those up. Make sure the detent still works. Looks good to me. Then the copper bridge goes on this piece. See, I also polished those caps up a little bit. And it's also keyed. Trying to show what I'm doing here. And I did also polish up these 2 points too. And it gets a spring, a washer, and then this little tiny cotter pin. Oops. Goes in there. And I'll have to bend that out a little bit. And you can see when I turn it one way, so that's connecting ground on the shaft to the negative side of the battery. When I turn it the other way, now it connects one side of the lights to ground to the negative side of the battery. So I just thought that was a little kind of an interesting switch construction on that. So we'll still have to clean out that one pot yet that was having an issue, and after that hopefully we'll be good. Okay, so I got it back in the cabinet. The switches seem pretty clean now. This thing really chews through the A batteries. I think I had it running probably less than 2 hours total for my testing, and my 6 volt total D cells battery dropped down to under 4. I think it was like 3.9. So it really chews through those batteries, and you can really hear the difference in the radio. I mean, before, I think when we were testing, we were at like 6 volts up here, 5 volts up here, I think, and now you can turn it all the way up. Same with these. You can really see it in the camera, the varying color, brightness. Got newer batteries down there. I think I checked those are about 5 volts right across the battery pack, so that's why I feel comfortable turning the adjustment all the way up. I don't want to give these tubes more than 5 volts because that's what they're rated for. So I think the next thing I'll do is change this tube here for a power tube and see what difference that makes. And also the light drags down the battery quite a bit as well. So if I turn this on at night mode, see how much quieter it is.
WGPA. I started listening to it in the early 50s, and I still listen to it every day if I can. And I just want to thank you for the wonderful music you are playing for our entertainment. It really is great.
So let's change that out. To do that, we have to hook up an extra C battery here and B battery here. So I'm going to hook up a 45 volt battery pack across that and a 4.5 volt across that and install the tube and see what we get done. So I just rigged in those battery packs there. If I do this permanently, I'll have to do something different with that. So I got my regular B battery over there. And I still have to figure out what I'm going to do about the C battery. It's kind of, one of my clips I glued on came off, so I'll probably have to make a stand or something for that. Anyway, we got the tube in there, batteries in there, so let's see what we get.
WGPA from Bethlehem, Pennsylvania. Streaming 201100.com. 32.
I don't know if you heard that, but the station number is 1100. Notice that nowhere on any of these dials does it say 1100. This must be meters, I'm thinking. So you can calculate that. I believe wavelength, the speed of light is equal to frequency times wavelength. So if you divide the speed of light by 250, would you get 1100? Let's calculate that. Yeah, so the speed of light divided by 250 gives you about 1200 kilohertz, I think. Yeah, 1200 kilohertz. So yeah, this would be wavelength in meters on this dial. And these ones just go from 0 to 100, so just arbitrary increments on there. I don't notice a whole lot of difference with the power tube installed. Okay, camera out of memory. But what I was saying was I think this is about the performance I would expect to get out of this. It only has 2 stages of RF gain, whereas a lot of the other, well, maybe not from this early, but by the late 20s most radios had at least 3 stages, sometimes more, of RF gain. So I think I'm pretty satisfied with the performance this is giving. I really like this front panel, this painted wood on metal. I really like to know how they did that. It's not the best sounding radio, but I'd imagine it would be sufficient for someone back in the 1920s. This one I'd probably be okay with running with the lid down, because none of the tubes in here get really that hot. Look how much dimmer the power tube is. You even see it on the camera? Oh, there you can. That's the oxide coated filament. So notice how much dimmer that is than the thoriated tungsten. Those glow a nice low red, whereas these are a nice bright yellow, and the pure tungsten is a nice bright white. I don't have any of those though. I think that's going to be about it for the electrical on this. I'm going to need to tidy up the batteries a little bit, but other than that, I'm pretty satisfied with this performance. I think the cabinet is not the best. Some of the finish coming off there. There's a lid too. One interesting thing I wanted to mention also is the holes in the back of the cabinet don't exactly line up with the connection. So the hole is over here, and you have to kind of feed the speaker wires over to there. And this tube is barely warm. You can feel that it's warm, but barely. That one doesn't hardly feel warm at all. That's the speaker I'm using, by the way. It doesn't sound that clear, but that's the way it comes in on a lot of my radios. It's not a real powerful station. See if we can find something different.
We'll recalculate your personal credit score for only $99 and repair your personal credit for free. Just be one of the first 10 callers. Take our personal credit challenge. Get your credit score to a 720. 800-482-4094. Call now to recalculate your personal credit score for only $99.
Plenty of gain though, you can get it decently loud.
800-482-4094. Don't miss this great free credit repair.
That's probably out of Philly, that's KYW.
800-482-4094.
The eyewitness for the forecast tonight.
Yeah, that's KYW.
The low of 31. Tomorrow, increasing clouds, rain, snow mix developing overnight. High 47. Wednesday, rain, snow mix changing over to all snow and a high of 40. Thursday, limited clearing with lingering flurries, a high of 45. Friday, partly cloudy, areas of flurries.
Just got done with that bomb cyclone, whatever they're calling it. Had a really strong wind just took out a bunch of people's power. Now it's supposed to get more snow. But next time the power goes out, I should be all set with this. Assuming I have a very large supply of D batteries. Well, that's going to be it for now. I hope you enjoyed this little look at a 1926 Sparton 5-26. Thank you for watching.
Check on Wall Street, sponsored by Crash Proof.